All right, we're going to keep talking about parallelograms, and what we've been doing so far is learning to identify the properties of a parallelogram. So we've looked at parallelograms and then we've said what properties they have. So now what we're going to do is be given the properties and determine whether or not something is a parallelogram. So take a look at these 5 theorems here. These are all things that you already kind of know, so we're going to go really fast through them. The first theorem says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. And so over here we're just going to draw examples of all these theorems, and when you see these things you're going to know that it's a parallelogram. So we need a quadrilateral with a pair of opposite sides that are parallel and congruent. So if you're drawing that, that's going to look like this, and it's going to have one pair of opposite sides that are parallel and congruent. So when you see that, you know that you're dealing with a parallelogram, even though you don't know anything about the other sides or the other angles. All right, the next one says if both pairs of opposite sides of a quadrilateral are congruent. So again, same shape, something that looks like a parallelogram, and then when you encounter both pairs of opposite sides being congruent to each other like this, that's also a parallelogram. And see, we don't know anything about it being parallel, and we don't know anything about the angles, but that's enough to determine something is a parallelogram. All right, then if both pairs of opposite angles of a quadrilateral are congruent. So again, you'll see parallelogram, you'll see shapes like this, and they'll have both pairs of opposite angles marked as congruent for you like that. So when you see that, okay, nothing is known about the sides or the side lengths. So we don't know parallel, we don't know congruent, but we do know the opposite angles are congruent, so that means this thing is a parallelogram and all the parallelogram rules apply. All right, next one, if an angle of a quadrilateral is supplementary to both its consecutive angles. So let's say we have our parallelogram shape. Oh, that's a pretty good one, huh? Right, and it has angle 1, angle 2, and angle 3. And we don't know anything about the sides or if anything's parallel, but we do know that the measure of angle 1 plus the measure of angle 2 equals 180, and if the measure of angle 2 plus the measure of angle 3 equals 180. Okay, so that is an angle of a quadrilateral is supplementary to both of its consecutive angles. So angle 2 is supplementary with 1 and 3, then that means this is a parallelogram. All right, the next one, if the diagonals of a quadrilateral bisect each other. So we have our quadrilateral, and then it's going to have 2 diagonals. So one from this corner to that corner, and from this opposite corner to its opposite. And if those bisect each other, which means these two are going to be the same, and these two are going to be the same. If that happens, you know that you're dealing with a parallelogram and all the parallelogram rules apply. All right, so the problems you're going to do are going to look like this. It says find the values of A and B that would make the quadrilateral a parallelogram. So we look, well, for A, we would need for these two sides to be congruent to each other for this to be a parallelogram. So 7A would have to equal 2A plus 12. Now we can solve that. I don't know if y'all can hear that, but there's a dog outside my house barking its brains out. But anyways, so we're going to come up with A equals 12 over 5, or A equals, and do 12 divided by 5, and you'll get 2.4. Okay, so that's what A equals for this to be a parallelogram. Now, for B, we look at our angles. So we have this angle and this angle, and since they're consecutive, meaning one right after the other, we know from here that our consecutive angles have to be supplementary. So 10B minus 16 plus 9b plus 25 has to equal 180 degrees. So we're going to combine like terms. So I know my b's look like 6's, but y'all should be used to that by now. 19b plus 9 equals 180 minus 9, and I have 19b equals 171. Divide both sides by 19, and I'm going to get that b equals 9. So there's my a and my b. That's what they'd have to equal for this shape to be a parallelogram. All right, a couple of quick examples. Determine if the quadrilateral must be a parallelogram, and then justify your answer. So we're going to say yes it is or no it isn't, and then we're going to say why. So first one, we have a quadrilateral with 3 angles given to us. Well, these 2 angles added together add up to 180. And these 2 angles added together add up to 180. So yes, this is a parallelogram, and it's because the consecutive angles are supplementary. All right, now we look at our next picture, and we have one set of opposite angles that are congruent. So this is going to be a no, because it does not tell us that both pairs opposite angles are congruent. So I'm going to say both pairs of opposite angles are not congruent. So that means it's not for sure a parallelogram. Then I look over here and I see I have 2 sets of sides that are congruent, but my rule said it had to be opposite sides like this, and those opposite sides are not congruent. So this is going to be no, and it's going to be because opposite sides are not congruent. And then we have our last one. It has 2 angles here that are congruent, which these 2 angles are consecutive angles, right? And then we have one set of parallel sides, but we don't know anything about those sides. So this is going to be a no, and the reason is because our consecutive angles are not supplementary, right? Which is one of the rules we needed. And we don't have anything to tell us that our opposite angles are congruent, so our opposite angles are not congruent. So nothing in here should make you think it's a parallelogram. All right, last example. Show that this quadrilateral JKLM is a parallelogram by using the definition of a parallelogram. So we have these points. It says J is -1, -6. That's J. And K is -4, -1. So K. 4, 5 is L, and 7, 0 is M. And now we need to connect all of these, and we're supposed to prove, that this is a parallelogram. All right, kind of looks like a rectangle to me, but you'll learn later that rectangles are parallelograms, so it doesn't matter. The way that we can figure this out, we know our rules, right? Our rules say that, let's go back to our rules on the other page. If we have one pair of opposite sides that are parallel and congruent, or if we have both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent, or consecutive angles are supplementary, or the diagonals bisect each other. So we can use any of those things, and if we could just prove one of them, we'd be good to go. So there's lots of things we could do. What I'm going to suggest is that we look at the side over here, and we make a little right triangle right here. And then we're going to make that same little right triangle right here. And when we do that, we need to record these numbers. So to go from K to J, we go down 1, 2, 3, 4, 5. So down 5. And to go from there to J, to get over, we go over 1, 2, 3. And over here, from L to M, we also go down 1, 2, 3, 4, 5. and we go over 1, 2, 3. Now you may not realize it, but what we've just determined is that the slope of line KJ, or segment KJ, is equal to -5 over 3. That's the rise over run. And the slope of LM is also equal to -5 over 3 because that's our rise over run. So we've proved that they have the same slope, those two sides. Now we need to prove that they're the same length, right? Well, to prove they're the same length, these kind of look like little right triangles, don't they? So we can just do the Pythagorean theorem. So for KJ, okay, we're going to say that KJ is equal to, and this may be different for you, but it's good to practice. You know, when you do the Pythagorean theorem, we're going to do this squared plus this squared equals this squared, and then we're going to take the square root. So we'll just take the square root first, and then do -5 squared plus 3 squared. Type that all in your calculator if you want, or you can just do -5 squared is 25 plus 9, it's the square root of 34. Because we don't care how long it is, we just want to see if LM is the same length. And it's going to be also -5 squared plus 3 squared, which is the square root of 34. So we have that KJ and LM have the same slope, and they're congruent. So those two opposite sides are parallel and congruent. And then the conditions for parallelograms, you can write those down. Those are the 5 things that we just saw on the other side, plus the definition. So that's the definition of a parallelogram, which says it has 2 sets of parallel sides. And then the 5 things that we just had on the other page. So that's it. Have a great night.